Hello, beautiful, wonderful young minds out there. Welcome to Pinpoint. I hope that through this material you will experience meaningful learning and gain deep understanding of the relevant competencies. And if this brings you good vibes, do hit the like button and share with your like minded friends. Also, don't forget to hit the notification bell for new video lessons in the future. As you already know, forces in the first law and the second law describe the forces acting simultaneously on the body, and the motion is determined, like the forces applied on the rope by the opposing teams in a tug of war. The laws of motion are not independent of each other. Motion depends on the force and mass of the object. Visualizing with all the applied forces, moments, and resulting reactions on a body in a given body. These quotes seem to resonate with Newton's third law of motion and action and reaction, isn't it? According to Newton's third law, there is no such thing as an unpaired force in the universe. Weighty, isn't it? The table rests on the floor just as the book rests on it, and the floor pushes up on the table with a force equal in magnitude to that which the table presses down on the floor. The same is true for the floor and the supporting beams that hold it up, and for the supporting beams and the foundation of the building, and the building and the ground, and so on. Or the very reason we are able to sit, stand, walk, and run is due to reaction forces from the ground. These pairs of forces exist everywhere. It was like third law of motion are more visible to us in nature and our daily lives. We encounter such examples in every moment in our lives. Sir Isaac Newton's three laws of motion explain the effect of force on an object. It is often said that every action is followed by a reaction. This is true for forces and physics. Newton's third law explains the reaction of an applied force. This law is also known as the law of action and reaction or the law of interaction. In this lesson, you will be able to state the law of interaction. As with the second law, the third law of motion builds on the first two. Having defined the force necessary to overcome inertia, the third law predicts what will happen when one force comes into contact with another force. As the third law states, when one object exerts a force on another, the second object exerts a force on the first force equal in magnitude but opposite in direction. Let's shed light on this by identifying the action-reaction forces in each situation. The girl is applying force to the tree by leaning against it. The tree, on the other hand, applies an equal and opposite force to the girl. If it didn't, she would go right through it or else it will topple over. A man is propelled upward and then down into the swimming pool as he jumps on the diving board. He exerts the downward force on the diving board, and the diving board simultaneously exerts an equal force on the man, but in the upward direction. The hammer strikes the nail, exerting a force on the nail, so the nail exerts a force back on the hammer, meaning the force of the hammer on the nail will be equal in magnitude, but opposite in direction, to the force of the nail on the hammer. The girl pushes her foot against the ground with her foot. Then reaction occurs when she moves forward on her skateboard. The reaction is always equal in strength to the action but in opposite direction. When you are holding a ball in your hand, the reaction force to the force of gravity on the ball is force exerted by the ball on the hand. Notice that there is always an action and reaction of forces between two objects. But it is critical that you understand that the forces exerted back is the same type and magnitude, just in the opposite direction. Remember that a force is a push or a pull upon an object, which results from its interaction with another object. Forces result from interactions, according to Newton. Whenever objects A and B interact with each other, they exert forces upon each other. So there are two forces resulting from this interaction, and these two forces are called action and reaction forces, and are the subject of Newton's third law of motion, formally stated as law of interaction. Generally states that in every action there is an equal and opposite reaction. This law explains how forces are balanced in nature by an equal and opposite force. This law gives us the magnitude and direction of the reaction force, which is useful in the numerical computation of forces. Also, this law tells us that a force exerted on any object is always exerted back by an equal magnitude of force, but in opposite direction. Always remember that in this law, forces always comes in pairs. These are called action and reaction forces, and they do not act on the same body. In determining the action and reaction forces, be able to identify first the action that requires force, and then identify the reaction force that counteracts the action force. Here are some examples of Newton's third law of motion in real life situations. When rowing a boat, you apply force propelling the water backwards, and the water provides an equal and opposite force propelling the boat forward. A squid propels itself like a rocket. It takes in water and expels it in sudden spurts. The forward reaction of the water pushes the squid forward. Notice that the bamboo cannon recoiled backwards when fired was due to the force derived from gas pressure. Finally, I give you one golden example. The golden rule does not only apply when you are talking about good deeds. In science, this rule has its counterpart, as Newton described in third law of motion. Well, probably the law of interaction is the easiest among the three laws, and you should agree that whether you push gently or strongly in life, it will give back to you valuable lessons, or one that you may call charge to experience. Nonetheless, I hope you learned something today. If you have questions, please do in the comment section below. You may like and share if you ever do, and if you want to avail my other video lessons, just hit the notification bell. Thank you for watching and definitely enjoy studying. God bless. See ya!